Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Class 11th. Class 11th. Physics. We are discussing projectile motion. Our today's topic is in projectile motion. Today we may discuss time of flight. Time of flight. Time of flight. Let us take it projectile. It is having a certain initial velocity u. It's moving with a certain velocity u. We have already resolved this u into two components, u cos theta and u sin theta. U cos theta along x-axis along horizontal line and u sin theta along vertical line. Okay. Now we know that if a point P, already discussed it, point P, it is having a coordinates x and y. Its position is we can say this projectile have a position at point P with coordinates x and y. Let h be its maximum height attained. After that it may descend. Okay. We have already thrown the projectile, which we have already discussed, with an angle theta. We know that from this place to this place, it is called a trajectory. It is called a trajectory. We can name it OB somewhat, or maybe OA, B, OA, something. It is y-axis and it is x-axis. We know it. Okay. It is its maximum attained height. After that, it may descend. Okay. What do you mean by time of flight? It is a total time. It is a total time in which the projectile may remain in flight. Or it is the total time in which the projectile may remain in air. For example, if we throw projectile from this point O, it remains from this point A, in air. In A, it touches the ground. So we can see from this point to this point, while going to this trajectory and reaching to this point A, the time taken by this projectile reaching in point A, that is the time of flight. From when this projectile is thrown, when it is thrown in air, and when it touches the ground after certain time, that time is called time of flight. This time of flight, if we show it time of flight. This time of flight, T may be shown by TA plus TD. That means time of ascending plus time of descending. From this point to this point, we may take its time of ascending. It is increasing, and after that it is decreasing. We can show it is descending. It is ascending. TA. So we can say time of flight T is equal to TA plus TD. But TA is always equal to TD. So we can say this time of flight T is equal to twice TA. We can write it TA plus TA. That would be equal to twice TA. It is a time of flight. But we know that at this point there will be vertical velocity will be Vy at point P. What is our vertical velocity? That is along y direction, that is Vy. Vy would be our vertical velocity at point P. It is our vertical velocity. Okay. And at that time, After this, there will be ta, t would be equal to ta, t would be equal to ta. And when the body reaches here, this vertical velocity vy comes to 0, and it starts descending. It starts descending. So we can say vy attains its maximum value, and then it goes to it attains the 0 value. It does not move further, and so it's now descending. It goes to out. Now vy goes to in negative value. So it attains. Let us take it is equal to 0. At that point, it attains the value 0. At that point, it attains the value 0. We know that the equation of motion, first equation, v is equal to u plus at. Here, instead of v, we may write vy. Vy is for u. Instead of u, we can write u sine theta. Instead of a, we may write g, but here it is not plus, it is minus. Instead of a, we may write g. Instead of t, we may write ta. G, T, A. So we can use sine theta minus G, T, A. Instead of acceleration, we write acceleration due to gravity. And at every point, there is an attraction of due to this earth. G is involved at every point, here, at every point. आखिरकार जी जोर हो जाता है तो यहाँ फिर वो गिर ही जाता है. So, but where Vy is equal to 0, so we can take Vy is equal to 0 is equal to u sine of theta minus gta, or I can take gta is equal to u sine of theta. That implies ta is equal to u sine theta divided by g. It is time of descent. Same would be the time of descent. Td would be u sine theta divided by Tg would be u sine theta divided by g. Okay, then the total time of flight. Total time of flight which we have to find. Time of flight would be equal to T would be equal to, which we have already found, 2Ta. That means that is equal to 2 into u sine of theta divided by g. So we got time of flight. T is equal to twice u sine of theta divided by g. Sometimes we have a problem to find the time of flight of a projectile, in which we have given initial velocity, we have given, and angle we have given. It is thrown at an angle of 60 degree. Inclined angle would be at 6 degree, and something u would be given. We can find the time of flight by using the velocity value u and this theta 60. Find the sine 60 and divide the g. We know they're 9.8 meter per second. We can find the time of flight. Okay, let us take another a sub part of this projectile. What do you mean by maximum height? This maximum height h. Maximum height. Maximum height h. Maximum height. It is the maximum vertical height attained by the projectile above the point of projection during its flight. It is the maximum height attained by the projectile during the flight. It is the maximum height attained by the projectile when above the ground or above the point of projection when it is in flight. So we can say this is the maximum height. It is the maximum height attained by. So we have to find h. What is the maximum height attained by this projectile? We know that this h may be a value of y. It is also equal to y. So we can say by the second equation of motion, s is equal to ut plus 1/2 of at square. We know it. So here is s, that is equal to y, or that is equal to h. Y, that is equal to h, maximum height. So that is equal to ut. Instead of u, we can write this u sine theta. U sine of theta. Instead of t, we have found the value of t. That what was that? T was U. We can take फिलहाल U TA plus 1. Here plus, here is no plus. It is minus because this acceleration is acceleration due to gravity is attracting towards this earth. That means it is the opposite direction of this projectile. Projectile direction is upwards. That acceleration due to gravity is downwards. So we can take 1 minus 1 bata 2 G TA square. Okay. We can take this u sine of theta instead of ta. We can write u sine of theta divided by g. It is 2. It is t. We have already found it. Find it. Minus 1 half g into u sine of theta. U sine of theta but g square. Okay. It is called h. It is called h maximum height. So we can find this maximum height. H is equal to u into u is u square sine square theta divided by g minus it is equal to g into 1 half g into u square sine square theta divided by g square. Square and this g may cancel. We get h is equal to u square sine square theta divided by g minus 1 half u square sine square theta divided by this g. 1g is cancelled. Okay. It is u square sine square theta divided by j. It is u square sine square theta divided by g. We can put it out. U square sine square theta divided by g out. Here remains just 1. Here remains minus 1 by 2. We can multiply it like that. U square sine square theta divided by g. It will be 2 1 by 2 minus 1 divided by 2. It will be equal to h is equal to u square sine square theta divided by g into 1 by 2. That is equal to 1 half u square sine square theta divided by g. This h would be equal to 1 half u square sine square theta divided by g. We can find also this maximum height. If theta is given, if u is given, we can find this maximum height also. Sometimes problem may be asked in exam and given there will be a given initial velocity of this projectile and there will be theta would be given, but it would be the inclination. You find the this height h. Easy. Giving the value 9.8 and we can find the side whatever, we can find the value of it. So this was about the maximum height. Well, thanks a lot. We can go ahead with this projectile for 2-3 days more.